Building a buttersmooth UI is extremely important in the world of native apps. It only takes a small amount of jank for people to think your app sucks. That's why one of my favorite things about Flutter is how beautifully it renders the animations. We can use the built-in profiler to see that we easily achieve 60 frames per second, even for this complex rotating radial menu. In today's video, you'll learn all about Flutter animations by building this menu from scratch. If you're new here, like and subscribe, and you can find the full source code on Fireship.io. Before we get started, I have a confession to make. In college, I failed trigonometry. I vividly remember scoring 0 out of 100 points on the midterm, and I probably didn't even take the final. And that's not good because we need to use trigonometry in this video to determine where to place the different elements on the menu. If we take a closer look at this menu, we actually have 10 different buttons stacked on top of each other. The open and close buttons stay in the middle, and then they scale up and down depending on whether or not the menu is opened or closed. When opened, all of the outer buttons will be translated or moved to a specific bearing from the center point. This is where trig comes into play because we need to calculate a specific XY coordinate based on an angle from the center. But don't worry too much about that, it's actually a very easy calculation. And this entire demo only takes about 150 lines of code, which is pretty crazy. And as a final touch, we'll also add a rotation to the entire stack of buttons. So that way it rotates clockwise when opening and counterclockwise when closing. To get started, you'll need to have a Flutter app, and then I also have vector math installed, and optionally Font Awesome for some better icons in the material. Then if we go into our main Dart file, you can see that I'm importing Dart math, and then I'm importing radians from vector math, and it's important to do the import like this because it has some conflicting classes with Flutter. Now we'll go down here to our material app, and we'll just add a scaffold, and for this demo we'll just have the menu fill up the entire screen, and for that we can use a sized box and have it expand to fill out the entire viewport. And then the child for that box will be our custom radial menu widget. When working with animations, the first thing you'll usually start with is a stateful widget. The only thing this widget is concerned with is defining the animation controller, which itself controls the duration of the animation, as well as the controls to tell it to play in forward or in reverse. What it doesn't control is the actual animation properties or the UI elements that are being animated. The first thing we'll do is add a mixin to this class called the single ticker provider state mixin. This will put the widget in ticker mode, which makes animations possible. The next thing we'll do is declare our animation controller, and then we'll actually define it inside of the init lifecycle hook. The most important aspect of the animation controller is the duration. At the end of the video, we'll stagger animations, which will all be relative to the duration that we define here. So in this case, the total duration of the animation is 900 milliseconds. We also have to pass this context to vsync, which is just a piece of boilerplate for animation controllers. In order to achieve 60 frames per second, this animation controller will tick every 16 milliseconds. I have it commented out here, but you could add a listener to this controller and then set the state every time it ticks. But we'll be using an animated builder in the next step, which makes this part unnecessary. Now we'll define the build method for this widget, and you'll see it returns a radial animation widget, which we'll define next. Just notice how it takes the animation controller as a property to its constructor. We'll be using the same controller to orchestrate multiple different animations at the same time. All of the animation logic will be handled by this radial animation widget. In order for it to take the animation controller as an input property, we add it to the constructor here, and then call super. From there, we'll define the build method, and it will start with an animated builder. An animated builder takes two main arguments. The first one is just the animation controller, and the second one is a function to build the UI. So basically, every time the animation controller ticks, it will run this builder function to rebuild all your widgets. We can control the state of this animation both in the stateless widget or in the stateful widget above. Because this is a menu, I want to make these methods a little more clear, so I'm defining my own custom methods called open and close. Open will run the animation in forward, and then close will run the animation in reverse. Now we can go up to our builder function, and the first thing I'm going to define is a stack, because remember, all the buttons are just stacked on top of each other. In the children array, I'll go ahead and add 2 floating action buttons, and because we're working with a stack, only the last button should be visible. That means you want the button that will open the menu initially to be the last item in the stack. If we open this on a device, we should see our blue open menu button, and then if we take that out of the stack, then we'll see the close button. That takes care of the initial setup. Now let's build the first animation that toggles this open and close button. For that, we're going to zoom out a bit and go to the top of our radial animation button, and first define a property called scale that is typed to an animation of a number. Then we'll define scale as a tween. A tween is one of those words that always makes me nervous when I see it. However, they're actually very simple, and they just translate to in between. So you give it a starting value and an ending value, and it will calculate everything in between. In this case, we're animating the scale of an element, and by giving it a starting point of 1.5, it will be 150% of its normal size. And then at the end of the animation, it will be 0% or invisible. The next thing we need to do is bind this tween to our actual animation controller. That gives it an actual duration to know how to calculate the in-between values. You could just pass in the animation controller directly here, but more often than not you'll use a curved animation to make your animations a little more exciting. I'm using fast out, slow in, but there's a lot of different curves you can experiment with here. The last piece of this puzzle is determining where to apply this animation in the widget tree. The scale animation is only going to apply to our open and close buttons in the middle. Flutter has this super useful thing called a transform widget, and it has a few static methods to rotate, scale, and translate a child widget, but it can also be used for super complex perspective-based 3D animations. So notice here how we've wrapped our floating action button in the transform scale, and then for the scale argument, we're passing it the scale value from the tween animation. So that means every animation tick or every 16 milliseconds, it will update the scale value of this element when it's animating. Now we'll go ahead and wrap the other button in transform scale as well. But you'll notice right now they're both using the same animation, so they'll be doing the same thing at the same time. We could write an entirely different animation for each button, but we can also be kind of clever here and instead just subtract 1 from the scale value, which will give us the opposite animation for the closing button. Always see if you can be clever first before writing a bunch of extra code. That completes the first animation. If we open it up on a device, we should see the button scaling in and out when clicked. The next challenge is to create a whole bunch of buttons that pop out of the middle when the menu is activated. We'll go back up to the constructor and add another animation that's very similar to our scale animation. This time we'll go ahead and call it translation. We'll give it a starting value of 0 and an ending value of 100. Then we'll define a curved animation, and then again make sure to experiment with the different curves. You have a whole bunch of different options here. Now we definitely don't want to hard code a bunch of floating action buttons one by one. Instead I'm writing a method called buildButton, which will take an angle as an argument, which is in degrees, and then it will also take an optional color and icon. This is the part where a little bit of trigonometry is going to help us write very concise code. What we want to do is translate each individual button at a specific angle from the center point of this menu. This needs to be done in radians and not degrees, but degrees are a lot easier to work with if you're a human being, because it's easy to reason about a circle when you think of it in 360 degrees. So the first thing we'll do is convert that angle argument to radians. Then we'll define a transform widget, and that allows us to actually pass in a transformation matrix. This is really cool because you can chain together different transformations by using Dart's double dot notation. We're not going to do this today, but in theory we could also chain together a scale and a rotation if we wanted to. In this demo we're only concerned about the translation, but we need to calculate the translation based on the XY value from the center point of the circle. We do that by taking the current translation value and then multiplying it by the cosine of the radians. That will give us the X value, and then to get the Y value we just take the sine of the radians. And even as a failed trigonometry student, I think I understand this. And that's all it takes to calculate that translation. The only other thing we have to do here is add a child widget, which will just be a floating action button that will take our icon and background color arguments. Now we can come back up to the widget tree to our stack and just call this button for every item that we want to add to the menu. We'll put the first button at 0 degrees, the next one at 45, the next one at 90, and so on. If you open up the app, you should have an effect that looks like this. At this point, the buttons are going in and out, but there's no rotation going on yet. What I want to show you is how to rotate the entire widget stack, but do it in a way that's offset from the main animation timeline. This is what you would call a staggered animation. First, we'll set up another number tween, and then we'll start at 0 and rotate around the entire circle to 360 degrees. We can make this staggered by going into the curved animation, and then instead of providing a curve, we'll provide an interval. This will tell the animation to start executing at a certain point in the animation timeline. With the first value being 0, that means the animation will start right away, but the second value is 0.7, which means it will end at 70% into the animation itself. In other words, the rotation animation will happen faster than the rest of the animation timeline. And now the interval itself will take the actual curve argument. So that takes care of the animation. Now let's come down to the widget tree, and then we'll wrap the entire stack in the transform rotate method. Now the stack will become the child of this widget, and then we'll set the angle value to the rotation value. The angle is also based on radians, so you'll want to do that conversion there if you're looking to do one full circle with 360 degrees. Now open up the demo on a device and you should have the super smooth 60 frame per second animation. And if you don't believe me, Flutter has a built-in profiler, so just run flutter run flag profile, and you should see that you have plenty of room to spare for even more animation and UI painting. I'm going to go ahead and wrap things up there. If you have any UI elements from popular mobile apps that you might want to see cloned on this channel, let me know in the comments. And if this video helped you, please like and subscribe. Thanks for watching, and I will talk to you soon.